So welcome to the NGINX Unit Update 2018. This session will be recorded, and what we are going to talk about here is the newest things that we released in the NGINX Unit project. We will show a very extensive demo of most of the new functionality, and then we will have the session for questions and answers on the software. So why did we build NGINX Unit? Unit is the application server that responds to the newest challenges of the infrastructure today. And currently, infrastructure is changing very frequently with the containers and cloud systems and different VMs. All kinds of servers are created on the fly momentarily. So the rest of the software has to adapt. There are multiple application stacks today, different kinds of application languages, and there are good reasons for having them in the same kind of environments. Also, applications today are being distributed into monoliths, from monoliths to microservices, and all kinds of different sizes of application and different approaches to their deployments exist on the internet. And all of that is managed with the newer deployment methods, with the CI/CD pipelines, with different kinds of APIs, configuration management systems, and so on. So NGINX Unit is the dynamic application server that doesn't have a concept of reloading things. It just changes configuration in memory and performs that instantly in the response to the API calls. As a result, you see the consistent management of different applications, different kinds of application stacks, or even versions of the same language. And of course, Unit is written in C. It's absolutely open source, and it shares the same development culture as the core NGINX project. So in a nutshell, over the last year, we had a lot of progress with the Unit project. We release on average about 12 versions a year, so about every month or so we have a new version coming out with a new functionality. So in the middle of the year, in April, we released the version 1.0, where we added the dynamic process management, we added more languages support, we added more security and hardening features. And right now, in October 2018, we're at version 1.4, and we added SSL TLS features and looking into adding the Node.js in the packages, and currently working actively on supporting Java. That is coming in future. So where should we look at the changes and the change logs and keep track on what's happening with the project? One of the best places where to look at that from the very technical perspective is the change log that is located at this changes.txt URL. And I'm pretty sure that many of you have already found it or read it at some point in time. So right now, we'll go through a little recap of what was happening during the beta stage of Unit, and then when it went out of beta with version 1. So those are just the excerpts from the changelog here. So one of the first things that we released in the very early life of Unit was the configuration persistence. When Unit starts, it takes its configuration state from the directory, from files, and then when configuration is changing through the API, Unit puts that information to those state files. We do not recommend changing the state files by hand and restarting Unit, because the configuration there might not exactly be supposed to be human editable. Unit is supposed to make changes consistently to those files and store the state using its own methods and its own concepts. So the state directory today also supports not only the configuration JSON itself, but also the certificate data. So once again, we recommend the configuration approach through API and the state to be saved by Unit. Next thing that we added was the timeout functionality for Unit to stop the processing of requests that take too long to execute. And in addition to that, we added the limits request property that allows you to have the limit on the number of consecutive requests processed by the same worker process of the application. Next thing is the virtual env for Python, and that is really popular for most production Python deployments, as it allows you to have multiple kinds of environments in the same system with different modules and different settings. So we had that one with the name of the parameter home. And the last one on this slide is the dynamic process management for the application processes. So the static process management just spins up the number of application processes that's equal to the predefined integer, and the dynamic process manager process management allows you to make that number variable depending on current load, and we will demonstrate that today. So next, with versions 1.6 and further, we added more application languages. We added Ruby module, so now we can support Ruby Rack applications. And the next one was the basic access login. So the access login currently is supported as one access log for all the applications, and it is done in the combined format. It is configured dynamically just the same way as any other property of Unit. Next, we added the configuration of environment variables in the applications. So the thing about the environment variables is that they are evaluated on the start of every application worker. So when you are changing an environment variable, the application workers that for which you are changing that environment variable will have to be restarted. However, environment variables can be set up specific to the application. And that means if you are changing one environment for one of the applications, the other applications are not changed or not restarted. The next feature here is the customization of PHP ini configuration. First, as a file path for the PHP ini file, and next for the individual PHP options. So further down, we added the execution arguments for Go applications. And in some of the latest changes with Unit, with versions 1.3, 1.4, first one that we have is the configuration of request body size, configuration of HTTP connection timeouts, and both of those, they are pretty standard configuration options that are required for any kind of application server. Next, we moved the control API location from / to /config. And that change allowed us to create more different items in the main URL, namely the certificates. So we added TLS support for client connectivity, and that functionality allows you to make changes to the SSL configuration, add and remove certificates, and replace the certificates based on the requirements through just the simple API calls. We changed the code to add a library for better support for different kinds of applications, and added the 408 response when closing keepalive connections. So within Unit 1.5, we are planning to release a Node.js application module as a part of the release. Currently, as of as after the release Unit 1.4, we have Node.js available in the code in the repository. So if you are compiling Unit by yourself, you can have Node.js support right now, but it requires a few extra steps to get all of your packages, all of the Node.js binaries together correctly in the same system. All right, So let's get to the most interesting part here. That is going to be the demo. So I will start with the great page that is not currently configured. So that's going to be our main website. And also we have a unit running right here with the minimal empty configuration. Unit processes in that case, they have just the main process, the controller, and the router process. A router process will be the one accepting the client connections. A controller process will be the one processing and managing the configuration. Now, first thing I want to show here will be our starting JSON configuration that we defined right here. So what we did there, we defined 3 different applications. And let me talk a little bit about what the application is. So at NGINX, we have a very diverse crowd of people coming from different backgrounds. And many of us come from countries which are not used to units of measurement by other countries. And the thing is, for us to better understand how many feet are there in a meter, or what does 72 degrees Fahrenheit mean, we're building this demo of a unit converter on NGINX Unit as a set of different applications running in different languages. So what we're going to be doing today is setting up this application from the way and from the state that it was with the very simple unit 0.1 and adding feature one by one down to the latest Node.js and TLS implementation. So let's start with a little review on what we have here with the listeners and the applications. So we have the application main page, and main page is a very simple PHP script that just generates a static index HTML. So we all admire the PHP language, and we gave it the very important task of generating some simple HTML. Now, in addition to that, we added 2 very simple unit converters as feet to meters written in Python, and this one Fahrenheit into Celsius written in Go. What you will notice here as a very interesting thing, we have the type of the application defined as external, because the Go binary that was compiled here is running externally to the rest of the unit processes and communicates with the router process through shared memory. OK, so the next thing that we're going to do, we will take this start file, and we will add it right here through our API. So let me talk through the curl command here, because we will be using this a lot today. So what we did for the unit API, we set it up on port 8443 here. And if you are doing that in a production environment on an IP address and a port, make sure you have appropriate level of security across that port. A unit that is taken in from our official packages doesn't have the API running on a port. It has it, by default, it has it running on a local Unix socket for better security. But just for simplicity right now, we set it up to run on a port, so the configuration is set up a little bit easier this way. So we're running this JSON file as the request body for the put request into the /config URL. So once we did that, we set up. We see that the reconfiguration is done, and we see 3 of our new applications are running right here in the list of processes. So we have our main page application in PHP, we have feet to meters in Python, and here's our external Go binary. Let's go to the web browser and see a couple of things here. Since we are running unit in this API, and that API is available with the web browser, we can see exactly the output right here. Next, let's go to the application itself and reload the page. All right, here's our converter, and let's see if it works. So we got 10 feet converted into meters. So the way this application is configured, the little frame on the right is working externally to this little HTML page and is executed by our small applications. Now, everybody was saying that it's really cold in the room, and someone from America told me it was something like 65 degrees. Since I have no idea what it is, let's see what 65 degrees is. It looks like it's 19.8. Maybe it was even colder in this room today. All right. Oh, apologies. It's 18.3. I didn't click on the correct button. It's 65 feet is 19 meters. All right. You see how complicated those units are. Now, so what we did there, we had a couple of applications running, but first of all, we didn't actually know which requests were coming to which application. Were we really having those apps running? You might think I just cheated here and put all of those scripts in a local JavaScript. Let's do this. Let's add access log to our configuration. So here's how we're going to do that. So we will take the access log file name. Well, let's put it into this tmp unit.access file name, and let's add it into the parameter that is called config/access_log. All right, we immediately see that reconfiguration is done. And if we do our tail-f into that file, oops, apologies, we have some permission issues there. All right, so now we're tailing this unit access file, and let's see what it is, 72 Fahrenheit. You see on every click that I'm doing, we have the request coming into unit. We see that immediately in the format of, in the combined format right there in the logs. And if I see what it is 3 feet in meters, we see that it's 0.9 meters, and we see a different application line right there. All right, so we have this bit running. Now access log is configured, and if I want to change the location of this, or if I want to remove access log, this is done the same way with this API. Now that we have 3 applications running, let's have another 3 applications right there. So what we added is the application that converts inches into centimeters. And that one is done. We immediately see that application process right here. Next, for every application that we configure, we also have to add a listener, so the application would be available on the network. So once we add the listener right here, we will see that the app will be available on the port that's defined right here in the URL of the listener. So for this application, this is port 8083. So for our inches into centimeters application, let's see what is 12 inches right here. This is 12 inches is 30.48 centimeters. Looks like 1 foot, probably. We'll see. Now, the next thing that we will add will be the application converting ounces into milliliters. Let's add this one. And that application is written in Ruby. That application will be right here on the port 8084. And the last one here, but not the least, is going to be our Node.js app, which is converting pounds to kilograms. And that one is alive on port 8085. All right, so I was showing something coming from the predefined set of small JSON files. And let's just see a couple of those JSON files, the way how they look there. So which out of those apps you want to see? Tell me. Node. OK, that's a great choice. That's definitely a great choice. Let's see how the Node application was configured right here. So our JSON object is extremely easy. We just defined Node as the script as the executable parameter and defined the type of the application as external. Now, if we go back and remember what was there as our application for Go, we will see that the Go app here was also set up with a type external. Now, what does that mean? It means that from the point of view of the core unit server, applications like Node.js and Go, they are of the same type. Those are different processes that are set up with outside of unit and communicating with it through that shared memory protocol. All right. Now, another thing that I want to show you, since we are looking at Node app, let's actually look at the code of that application itself. So what we did here with the app, it's really simple. We're just taking the URL, we're converting that from one unit of measurement into another, and just responding with that. Here's the interesting bit. It's right there in the beginning. We have the require unit HTTP module. So that Node module was compiled compiled from the sources of unit and is installed in the Node modules path. Now that it was installed in that Node modules path, we can use it from any of our projects once we do npm link into our local Node modules directory. Next thing that's really interesting is that when we are using the create server method here, we're using it not on HTTP object, but rather on unit object. And after that, when we are launching this same application with the listen method, we are actually defining a port. Now you might ask, we have one port defined in the unit configuration and a completely different port defined in the Node.js file. So here's what's happening here. If you launch this script directly, it will be responding on the port that's defined in the script. If the script is launched by unit using the unit's APIs, in that case, it won't be listening on the port, but it will be communicating with unit through shared memory. So this parameter will be ignored by unit. It's exactly the same idea as we had and we discussed in full in the previous demo last year when we were looking at the Go configuration and the Go apps. The only difference there is that Go apps had to be compiled into binary, and Node scripts don't have to be compiled. You can launch them, change them with just one less step. Okay, so where are we at? We have several applications. We have those ounces in milliliters, pounds, and kilograms. So on my driver's license, it says that I am weighing 165 pounds, which is all right. Looks like it's just under 75 kilograms. So that script is working. And the can of Coca-Cola drink here, it was about 12 ounces. 355 milliliters. That sounds about right. So our application is working here. All right, let's proceed to the next steps. Now that the application is running, we will define a few other things. So we mentioned that we can define PHP ini variables, and those variables can also be defined dynamically through this unit API. Let's take this API call. And now what we do here, it looks like we added the expose PHP parameter right there for our main page application, which means if we do a curl-i into our app, we should be able to see right here which version of PHP it is being served by. Now, if we take that same parameter, and actually, let's go even deeper into the parameter itself. We have options /admin /expose PHP. We have that the one. Let's put a 0 there. So what we have to do there, even though it's a number, it is in this particular option, it is still defined as a string for PHP. Let's see what happens when we do curl-i for that same URL. Now that exposed PHP header was removed from the output. So now we don't see it. Looks like our PHP options are working, and that was just configured directly. Now, if we go back to the browser and refresh our API, let's see, here's how it looks in our full output of the API. Pretty easy, huh? All right, let's go to the more interesting part. When we were looking at the application for that converts inches to centimeters, the thing is, I built it with a little flaw. If I click on that, you'll see that there is some bits of delay. So that little application that converts inches to centimeters and works on our port 8083, it is a little slow. Here's what we're going to do there. In order to show you how the process management works, we need to generate some real load. And it's easier to show the scalability of the application on the application that's not exactly perfect. So first of all, we'll set up our processes object for this application. Now that we did it, we set it up with the minimum number of processes as 2 and the maximum number of processes as 10. So immediately what we saw in the list of the processes, we saw 2 of our inches to centimeters applications. Now let's launch our curl to that URL, and let's do that several times. You see, every one of those little slow applications, they are waiting for a bit, executing their calculation, and then after they executed that, the application workers are free. Now, when the application workers are free, there is a timeout before a unit will scale them down. And that timeout is going to fire up right now, and we see how the process list and how our dynamic process management scaled the unused application processes down to the spare that we needed there. All right, so we have this thing running. Now let's see if let's see the other item that we can set up, which is the timeout for the applications. So we'll do that using the same faulty Perl application that's really slow. And what we will add is the timeout parameter to the inches to centimeters app into the object limits timeout. Now we've set it up as 5 minutes. Here's the thing. Our application was running for about 2 seconds or something like that, or a little bit more. So right now we see that the timeout is very strict, so the application is not working. If I change the timeout to 15 seconds, that application will work, and it takes it about 10 seconds to execute. So in 10 seconds, we should be able to see the result. Here we go. All right, so we have the timeouts tailored to the application. We have the dynamic process management set up here. And there was something I heard just in the hallway just recently. And it was related to the fact that it makes sense to scale out the Node.js applications. And there are process managers for that. But here's what we can do with Unit. Let's go back into our configuration right there, and let's go to our Node.js application, which is converting pounds to kilograms, LB to kg. Here we go, and we can see that we have a number of Node.js processes spun up. I think this terminal needs to be expanded a little bit. Here we go. Yep, so we saw how we just added a number of node processes, just like a normal process manager. All right, let's go next to even more interesting functionality. Let's go into the environment variable features. Here's what I'm gonna do there. So we have the application written in Python, which converts feet to meters, and in this application, we have something defined as an environment variable. So we're taking the environment variable color and we're modifying our output based on that environment variable. All right, let's do the same thing we're doing again, and that is define the environment variable as red right there to that application. So let's do that. Configuration done. Let's click on our feet to meters. Hey, it just caught it immediately. That was also pretty easy. So next thing we can do, we can just change it to something else. Let's say blue. And once we do that and update that here, we see that our background has changed to blue. Also really easy. OK, now we're getting to the most interesting part here, which is the dynamic SSL and TLS certificates. What I have here is the self-signed cert called self-PM. It's right there in the SSL directory. And what we're going to do, we will put that certificate itself, not a JSON in this case, as the request body, not in the config storage, but inside the certificate storage. First thing I want to show there is how that certificate file looks like. Let's take a look at the file. We have the certificate itself, and right there, right after the certificate, we have the private key. So what you do there, you define the cert and the key, you put them in the same file, and if you have the chain, you put all of the certificates in that file, and then you just give it to unit in the very simple request body. So let's do that. That command takes a moment. Now certificate chain has been uploaded. OK, let's take a look at the full output of the API. And let's see how that shows here in the certificates object. Let's refresh. Isn't that nice? We can see all the data about that certificate, including its validity and issuer and all of the other information. Now imagine you need to run some scripts on the validity of your certificates to check if your certs are all right or if they need to be replaced soon. All we need to do is curl, and we're going into our certificate storage, certificates, and then we're going into our certificate name self. Right there, there is the certificate chain. There is the first object under the name 0. Then it has the validity object, and there is the validity until. Here we go. We just got directly to the validity of a particular certificate in case we need to update something, in case we need to run some monitoring scripts. That makes a lot of sense to make those checks quite automatic. All right, so we added the cert, but what we didn't do, we didn't define where that certificate will be used. Here's what we're going to do. I will add another listener, and that listener will be on the port 8043. And in addition to the application main page, I will add the TLS object right there to that same listener object. So let's add this the way it looks right now, and let's just update the more user-friendly look on this. So we see our new listener 8043, which has application main page. It has that TLS cert, certificate self. Great. So here's another thing that I added there. I added the more or less real host name, which I bound to 12701. And it means I can actually take that same application right here and we can see that we have our self-signed certificate. All right, we have it right there. Let's scroll through this privacy items, and now we have our application running through HTTPS right there. But you know what? I think we're all serious people here, so we don't want self-signed certs. We want to make something more appropriate here for better use. I already generated a nice and simple Let's Encrypt certificate for that domain name, and I have it right there in the SSL directory. It's the one taken from Let's Encrypt with I called it this one, the full chain PM. What I'm going to do there, I will add that full chain PM as the different certificate with the name lab. And the next thing I'm going to do is I'll go to our listener object, and I will replace the certificate there. So first, let's get to the object correctly. There is a little trick there with the way how we defined it. So we'll go into listeners. Right there, we have so many listeners right now. Let's go into 8043, and there is that one has an object TLS, and there is an object certificate. Yes, we got the one with the name self. So here's what we're going to do. We'll take our very well-known method put, and we'll add the data binary with the name of the cert. We called it lab. That was lab. All right, here we go. We got the reconfiguration done. Let's go back to our browser and see if we can refresh it. We are getting into the keepalive here. So let me start the new private window. Here we go. We got the application running on the proper certificate without the security warnings. OK, so that was the example of the dynamic TLS. And basically, the run-through in about 25 minutes, the run-through on many unit features in a very quick fashion. OK, so at this point, let's go back to a couple of slides. And let's see what else we have there. So how to get more information on a unit. That is our documentation website, unit.nginx.org. Next, you can visit our blog posts, and we have plenty of different blog posts already posted over the course of the year. Next, take a look at our GitHub repository. This is where most of the community and development chatter is happening right now, with the different issues created, with the patches and pull requests, and with all of the development activity. And also, if you prefer some more old-school services, we have a mailing list, just very similar to NGINX mailing list, right there at unit@nginx.org. Well, at this point, we will have just a few moments to go through the questions, and I would say thank you. All right, here's the first question. There is a very great question about the security of Unit API, and by default, the way Unit runs, you create the unit that is run from our packages, or if you compile it in such way, the control socket will be a socket file in the file system. Now, the socket file is owned by the user that is starting unit, which is usually root. But the application processes that you define there, they can be run by non-privileged users. For example, nobody, the www data, or specific users defined for specific applications. Those users don't have write access to the socket file that's owned by root. So in our demo here, we changed the socket, the control socket, to a port that was available from the local system. This was done just for the sake of brevity of our commands, but in a hardened secure environment, your control socket will be owned by root, and your application processes will never be root. Mm-hmm. Yes, Vasily?
Yeah, thank you. It's really a cool demo, but I have a question. Does NGINX Unit work with SC Linux?
The question is, does NGINX Unit work with SC Linux? You're talking about the security enhancements there. Well, I don't think we tested it in that way. And frankly speaking, the only command from SC Linux that I remember is how to disable it. But we will have to follow up on how it works with SC Linux. Mm-hmm.
NGINX has a great feature for doing seamless upgrades when you do a version upgrade on NGINX. Requests can keep coming in while you're doing the upgrade. Is that also available for you?
The great question coming in, and I'll repeat that one. So NGINX has binary upgrades, and those allow you to have requests coming in while the upgrade between versions is happening. Does Unit have this same kind of functionality? Not currently, not yet. We have that planned, but not exactly clear the release when we are going to do that. And the thing is, Unit needs fewer of those operations because most of the changes that you're doing are done through that API change.
Yes, but you're going to do a version upgrade.
Yes.
Once a month.
Yes, currently at the version upgrade, you do need to either recompile and restart or make a service restart. Mm-hmm.
Yes? Basic question. The demo that you gave, each of those applications, were they attached to one unit, or was there one unit and all the applications were attaching to the same unit?
The great question, if those applications were different units or just one unit. The applications were running within the same unit, and inside of the same unit API, we saw all of those apps within the same consistent interface. So it's just one kind of software, one router process, one controller process in Unit, and a number of application processes that we defined during the course of the demo. Mm-hmm. Artyom?
Mm-hmm. The question is Unit available in default repositories of Debian and Red Hat?
The question is if Unit is available in default repositories of Debian and Red Hat. Currently, Unit is not available in those repositories, and our official recommendation, even for NGINX, is to take the software from our repositories because it has it is compiled in a way that, first of all, it's newer, and it's compiled correctly the way we support it. So for Unit, it's the same. We encourage you for the production use to take Unit from our own repositories. And for the engineers who have more customized environments, you can use any repositories or even compile it yourself. Another thing that we have is an official Unit Docker container that we update with every release. And you can try Unit in a Docker environment, just doing docker pull nginx/unit.
At what point for having an official package, somebody is going to write the settings exactly for you. So that was the
Yes. Thank you. Yes?
You said Java is coming in the future. What other functionality or new features are in the near future?
Apart from Java, our engineering is currently working on supporting WebSockets, as Node.js is often used with WebSockets. Then we're working on the routing functionality that will allow you to have a different kind of URLs within the same listener port and have that running with different apps. If Valentin wants to share more on that, here's Valentin, who is the team leader for Unit development, and he can cover more.
Thank you. So we are working on routing functionality. It will allow to route requests from ports to different applications depending on your request headers or request URL and any request parameters. And as well, we are going to add support for storing static media.
Thank you.
For the future Java extension, would that obviate the need for Tomcat?
No.
So the question was, just
Yeah.
for the recording, the question was about will the Java implementation require Tomcat?
No, we don't require Tomcat. We write our own implementation, but it will be completely compatible, and we are looking into Spring Framework and Spring Boot, so we're expecting to run any Spring Boot applications out of the box without any additions and any changes.
Vasily?
Yeah. What about caching support? Do you have any plans to add it?
So the question was about caching support. For the future, the way we see it, NGINX and NGINX Plus are the kinds of software that are designed for caching. And at the very ingress of your environment, you will still have NGINX and NGINX Plus that are doing that kind of functionality.
You can, in Python, you could use a LRU cache.
Yeah, for instance, just interesting to like central memory.
I have a follow-up question. Since you were running one unit and so many processes in the background, is it possible to multiplex to one port instead of opening up so many sockets on the front side?
The question was about multiplexing different processes or different applications in one port. It will be possible to do that once the routing is available. That way, whichever URL you're going to, or whichever URL parameter or other filters, you will be getting into the particular application. However, there is no way to choose which worker of a particular application you're going to. Those are considered stateless. All right, well, thank you for the questions and thank you for attending the conference.
Thank you.